Hey, this is Dexter from Additional Math. In this lesson, we'll learn how to sketch the graph of quadratic function in the completed square form. We'll also understand the gradient of linear equation in which a straight line is tangent to a curve and when it does not intersect the curve. In part 1, sketch the graph of y equal to 4 times of the square of x minus 1 plus 3. Next, find the value of m where the line y equals to mx minus 9 is a tangent to the curve y equals to 4 times of x minus 1 square plus 3. Lastly, find the range of values of m for which this line does not intersect the curve. Pause to give this question a try, and when you're ready, keep watching to learn how to solve this problem. Given a quadratic equation in the completed square form of y equal to a times of the square of x minus b plus c, the shape of a quadratic curve is mainly determined by a, the coefficient of x squared. If the coefficient of x squared is greater than 0, the parabola opens upwards and we will have a minimum point. On the other hand, if the leading coefficient is lesser than 0, the parabola opens downwards and we will have a maximum point. As our coefficient of x squared in the question is 4, a positive value, our quadratic curve will have a minimum point. The turning point of a quadratic curve will have the coordinates of b, c from the completed square form. This has something to do with the square of the quadratic function. When x takes the value of b, the square of it will be 0 and y will be equivalent to c, the maximum or minimum value of the quadratic function. Thus, the minimum point of our curve is found to be 1, 3. Since the lowest point of the curve is 3, the x-axis must be below this point. Also, the x-coordinate of the minimum point is 1, implying that the y-axis must be to the left of the stationary point of our quadratic. To find the vertical intercept of our quadratic curve, we will now replace x to be 0 into the quadratic equation to give us a y-coordinate of 7. And here it is, the sketch of y equal to 4 times of the square of x minus 1 plus 3. In part 2, given that the straight line y equal to mx minus 9 is tangent to our quadratic sketch, this means that the linear equation will now touch our quadratic sketch at exactly one point, when x equal to 2. Since this point lies on our quadratic sketch, we will now replace x to be 2 into the quadratic equation and solving for y will give the value of 7. With the x coordinate to be 2 and y coordinate to be 7, we can now substitute this pair of coordinates into our linear equation y equal to mx minus 9 as this coordinate 2, 7 also lies on our tangent line. Solving for m will give the value of 8, and the equation of this tangent is therefore y equal to 8x minus 9. In part 3, we have to find the range of values of m where the linear equation does not intersect the curve. For linear equation y equal to mx minus 9, the vertical intercept of negative 9 is fixed and this shouldn't change. This leaves us with only one component of the linear equation, that is the gradient m. We will now change the gradient of the straight line about the vertical intercept 0, negative 9. If the gradient m is equal to 0, it will be a horizontal straight line y equals to negative 9. Here, we can tell that there is no intersection with the quadratic curve. However, the question indicates that m must be greater than 0. As the gradient increases, in the range between 0 to 8, the slope of the straight line is steeper. However, there is still no intersection with the quadratic curve. When the gradient m is equal to 8, it will be the same tangent line found in part 2, y equal to 8x minus 9. Here, we can tell that the linear equation cuts the curve at exactly one point, as given earlier. The gradient now increases beyond 8. The straight line gets steeper in slope, and we can now see that there are two intersection points between the straight line and the quadratic curve. To answer the question where the linear equation does not intersect the curve, and the gradient m must be a positive, m must be in between 0 to 8, not inclusive. And that's the answer to this question.